Hello everybody, welcome to section 6.5. So today we're going to talk about the inverse trig functions, and you got a little bit of a preview on that on your last Kahoot where I was giving you the answer or the xy coordinates or the sides of a triangle, and you were telling me the angles where it happened. So basically you were switching back and forth and giving me an inverse. So to start out 6.5 today, and feel free again, just like we do in class, write down whatever you feel like you want to put in your notes. That's the most important. So I would say, starting back, way back in section 1.5, when we first learned about inverse functions, the whole idea is if I gave you a function f of x, and I said, could you find for me, please, what is the f inverse of x? And again, there's that -1 notation. It looks like an exponent, but it's just the function notation for the inverse. And the real gist of it was, to find the inverse is you basically switched your x's and y's. That's how you found inverse. Well, the good news, folks, is that the same thing happens when you're in trigonometry land. So what you guys have been used to doing is when I give you sine, cosine, tan, what has been going inside these parentheses? Do you remember? Yeah, angles, right? You're taking the sine of an angle, the cosine of 30 degrees, the tan of 4 pi over 3. And what you get out is you get out the sides of a triangle, or you get xy points, anything like that. So when you take the sine of 30 degrees, sine of 30 degrees is 1 over 2, because the sides of a 30, 60, 90 triangle have a 1 and a 2. Or you look at the y-coordinate at 30 degrees, and you know that the sine of 30 has a y-coordinate of 1 over 2. So that's what we've normally been doing. This is the way things have been working so far. I give you the angle, and then by taking the sine, cosine, tan, you give me the answer, which is the sides of a triangle or the xy coordinates. Okay, so now if we're going to go into inverse land, all we got to do is switch x's and y's. So now, what are we really plugging into? The sine inverse, cos inverse, and tan inverse is these triangle sides. You're absolutely right. Triangle sides, again, or xy coordinates. So that's what you're going to start to see inside the parentheses. And what is your answer going to be? The angle where it happens. Where is the sine equal to 1 over 2? 30 degrees. So your answers here are going to be all the angle thetas where you get those triangle sides. So really, here's the big question we're going to be asking when we do inverses. Where do I get those triangle sides? Or where do I get that x or y coordinate on the unit circle? At what angle? Either degrees or radians. And we'll see that both are very important. Okay, so before we jump into very simple examples, feel free anytime, folks, on this video to just pause, take a break, write down some words, anything that you need, and then just unpause and come back. All right, let's start example number 1 and 2. So the idea is, can you simplify or evaluate each one of these without a calculator? Mental math. So the first one says, can you find the sine inverse of 1? What is the sine inverse of 1? What's that equal to? And again, what you see inside the parentheses is not an angle. This is the x and y coordinate, or it's the sides of a triangle. So basically, here's what you're thinking. In your brain, you think, oh, to go backwards, to undo the inverse, you think the sine of what angle would give you 1. So think about your unit circle. Take a minute and look around your unit circle really quick. Pause, and I'll tell you the answer. Where is the sine equal to 1? All right, did you get 90 degrees or pi over 2? That's absolutely right, at pi over 2. So the answer here would be, what is the sine inverse of 1? At what angle do I get 1? Is at pi over 2, or 90 degrees. That's the answer. So notice that if I go backwards, the sine of pi over 2 is equal to 1. And we're just going backwards. That means the sine inverse of 1 is equal to the angle pi over 2. Let's try number 2. Same idea. How about the cos inverse of -1? So again, you think here, you think, okay, the cos of what angle would give me -1? All right, why don't you pause the video, look at your unit circle, and can you find out where is the cos equal to -1? Remember, when you look at your unit circle, the cosine is related to the x coordinate. Now I was going to forget to mention that the sine way over here on the left was equal to the y-coordinate. So at which x-coordinate do you get -1? If you said 180 degrees or pi, you are right. Good job. The cosine of pi is -1. So therefore, the cos inverse of pi, the cos inverse of -1 is pi, or 180 degrees. See how we're going backwards? Your answer is now the angle, versus before you would plug the angle in and get the x and y coordinates, or the triangle sides. Let's keep going. So that asks a really, really important question now. How about one more? Can you try this on your own really quick? I'll pause it, you pause it, and I'll meet you back here in about 5 seconds. All right, welcome back. So when you look around your unit circle and you find out where is the sine inverse of 0, you're asking yourself, the sine of what angle gives me 0? And again, sine is related to the y value. So along your unit circle, if you looked and see where is sine, where is the y value equals 0, hopefully you got over here and over here. So I would say the sine of 0, or 360, and the sine of 180, or pi. So the sine inverse of 0, therefore, is 0 and pi. Okay, that's good, but normally when we take the inverse, we only want one answer, not both. So we need to restrict our range of angles. So here's what the problem is. I'm going to tell you right now, the sine inverse of 0 is going to be 0, but it's not pi. Okay. There's a little bit of theory behind it, and it's a little bit boring, so I'm going to shorten it really quick and tell you the gist. Remember a sine curve? Sine curve looks a little bit like this, right? Do you remember how we checked if this is a function? Vertical line test, right? The vertical line test should be totally fine. Vertical line test, fine. This guy's a function. Do you remember how we checked to see if he has an inverse? Yeah, horizontal line test. You remember that guy? So if you draw a horizontal line, does he go through only one point? No. So does the sine actually have an inverse? No. But the problem is, mathematicians weren't happy with that. They really, really wanted to have an inverse of sine and cosine and tan. So what they had to do is they're going to restrict the quadrants where we're going to play. And here's what I mean up here on the top left. When you take the sine inverse, I'm going to tell you right now, here is the sort of the end of the joke. When you play with the sine inverse, you're only going to get answers, angles, in quadrants 1 and quadrants 4. Why? Well, it's kind of related over here to when we talked about the horizontal line test. We couldn't use the entire function. We only had to use a part of it. So instead of using answers from all 4 quadrants, the sine, the inverse sine, is only going to play in quadrants 1 and 4. Similarly, because of the horizontal line test, the inverse tangent is also going to only play in quadrants 1 and 4. Similarly, because of, again, horizontal line test, the inverse cosine is only going to play over here in quadrants 1 and quadrants 2. These are really, really important steps here that I would definitely write down in notes. Big star here. Because now when you find inverse trigonometry here, your answers are going to depend on which quadrant you're playing in. So here's a really, really good summary. And I love this little diagram here. It helps me all the time. Inverse sine and inverse tan live in these 2 quadrants. So all my answers for inverse sine and inverse tan questions will only be in quadrants 1 and 4, never in 2 and 3. That's why way back when, up here on top, that's why we crossed out pi as an answer. Notice that pi is way over here. That's not in quadrants 1 or 4, right? So we couldn't take that answer. That's why the answer of sine inverse of 0 is only 0, because he lives over here where sine inverse plays. Similarly, here comes cos inverse. Cos inverse only lives in quadrants 1 and 2. So all your answers for cos inverse can only be in 1 and 2, not 3 and 4. Again, the whole reason comes from the whole horizontal line test, which is a really boring explanation, and remind me to tell you a long time from now, because it's really boring. Okay, keeping that in mind, guys. Here we go. Let's play. Look at all these great examples. I'll keep that diagram up here, though, so you can see it. Let's start with the first couple of them, and I'm going to let you go free and try a couple of these on your own. Let's try number 1. Number 1 is the sine inverse of 0. Well, we just did that on top now. Sine inverse only plays in quadrants 1 and 4, right? So you think about now, where is, on your unit circle, where's the y value equal to 0? And along your unit circle, you know that the y value is equal to 0 at 0 and pi. But because sine inverse only lives in quadrants 1 and 4, we have to cross out pi, and that's not our answer. So our only answer, the sine inverse of 0, is 0. Let's try number 2. On number 2, I want to find the cos inverse of 0. So you're doing two things here, folks. You're going to find out where along your x coordinates, along your unit circle, is x equal to 0. Also keeping in mind over here, remember, that cos inverse only lives in quadrants 1 and 2. So on your unit circle, where is the x coordinate equal to 0? Think about it for a sec. Did you basically get north and south? You're totally right if you did. So at pi over 2 and 3 pi over 2, or 90 and 270. That's where the cos inverse, that's where cos equals 0. But we can't take both of those, right? Because cos inverse only lives in quadrants 1 and 2. So I can't take this one down here. I can only take this one as an answer because that's where cos inverse lives. So your final answer, what is the cos inverse of 0? I would say pi over 2 or 90 degrees. One more. Let's try number 3, and I'll let you try the last 3 on your own, and I'll come back and check with you. All right, how about the tan inverse of 1? All right, you think about your unit circle. Where is the tan equal to 1? Tan was y over x. Where is that equal to 1? We did a bunch of these back when we were doing the Kahoot. And you remember that happens usually on the type of 45 degrees. Because you have a root 2 over 2 and a root 2 over 2. And that usually cancels to just 1. So can you think for a minute, where is the tangent y over x equal to 1? All right, I got over here at 45 degrees, or pi over 4. And over here, because remember, tangent is also positive over here. All students take calculus. So tangent is positive over there. All right, but you remember, based up here, that tan inverse only lives in quadrants 1 and 4. So tan inverse cannot take this one. The only answer would be here. Final answer, what's the tan inverse of 1? I would say pi over 4 or 45 degrees. All right, hopefully that's going okay. Definitely a couple of steps here to think about, but you're getting the hang of it. This would be a really good time to pause the video and try numbers 4 through 9. If you're daring, try 10 and 11 on your own too, and come back here in about 5 seconds and I'll work through each of them with you. So why don't you pause right now, try the next 6 or so on your own, and I'll see you back here in a couple minutes. All right, shall we check and see how we did? Number 4, the sine inverse of 1 over 2. If you checked your quadrants, this should be pi over 6. It would also be 5 pi over 6, but again, that's not in the right quadrants. That's in quadrant 2, and sine inverse can only play in quadrants 1 and 4. Number 5, the cos inverse of negative a half. All right, cos is negative in quadrants 2 and 3, but remember up here, we know that cos inverse only plays in 1 and 2, so we have to take the answer that's in quadrant 2. Where is the x coordinate equal to negative 1/2? I got 2 pi over 3, or 120 degrees. Number 6, how about the sine inverse of root 2 over 2? Okay, I'm looking around my unit circle. Where is y equal to root 2 over 2? Remembering where the quadrants are, I have a couple of choices, but I can only stick with quadrants 1 and 4. I got pi over 4, or 45 degrees. Number 7, how about the cos inverse of negative root 3 over 2? There's that negative again. And cosine is negative in quadrants 2 and 3, but I can only play in quadrant 2, because that's where cos inverse lives. I would say this happens at 5 pi over 6, or 150 degrees. Number 8, the sine inverse of root 3 over 2, that's positive. Sine is positive in quadrants 1 and 2, but the sine inverse only lives in quadrants 1 and 4, so I'm going to be in quadrant 1. Where is your unit circle? Where is y equal to root 3 over 2? First quadrant, I would say 60 degrees, or pi over 3. Last but not least, how about number 9? A tangent of root 3, tan inverse of root 3. Well, it's easier when it's a fraction, right? Because then I can see the x and the y coordinates, y over x. Okay, well, tan inverse only lives in quadrants 1 and 4. So let's see, looking around my unit circle, if I put my y over my x and get a positive root 3 over 1, I think that's going to happen again at 60 degrees, or pi over 3. How did those go? Did you do okay? Again, not too terrible, but just a little bit of extra thinking. All right, I'll pause here again. So if you want to try number 10 and 11 on your own, they're labeled as tough ones, and they're labeled that way for a reason. So I'm going to see what you got. So why don't you pause it and try number 10 and 11, and I'll meet you back here in a minute. All right, welcome back. Now, the reason why this is tricky, this is kind of funny. Sine inverse. I want to find out where is the sine inverse of negative a half, meaning on my unit circle, where is the y equal to negative a half? Okay, I'm going to wander over here on the left side for a sec. All right, you hopefully got two answers here. You hopefully got that sine inverse is negative over here and over here, meaning this is probably 7 pi over 6 and 11 pi over 6. And you thought, oh yeah, well, sine inverse only lives in quadrants 1 and 4, so therefore I can't take this one over here. I must only take this one. And you're right, that is the answer. But here's the funny part. Did you put your answer was 11 pi over 6? Good try. It is 11 pi over 6, but we can't write it like that. And here's the funny reason why. Okay, come over here to the left again with me. If I was to literally draw the angle 11 pi over 6, watch, here we go, ready? I'm going to start at 0. I'm going to draw 11 pi over 6. Means I have to go this way, counterclockwise, through quadrant 1, quadrant 2. Oh, no. Remember, I can't even go there. Sine inverse doesn't play over there. So I can't even draw an angle through those quadrants. So if I want to get to 11 pi over 6, because that's my answer, and I can't draw it going this way because I go into some illegal quadrants, I guess the only way to get there is to go clockwise. Interesting, right? So therefore, the answer is not 11 pi over 6, it's clockwise, so it's negative 1 pi over 6. So the answer kind of is 11 pi over 6, but because we can't draw it, because 11 pi over 6 would go through quadrants 2 and 3. Remember, sine inverse doesn't play in quadrants 2 and 3, so you can't even draw that answer. The answer is negative pi over 6. All right, pause it one more time. Now that you know that trick, why don't you try number 11 on your own and come back and see if you got the right answer or did you get trapped. All right, tan inverse of negative 1. So that's usually the 45s, right? All right, I'm going to come over here and think about it. Tan inverse. Well, tan only plays in quadrants 1 and 4. And where is it negative? Probably only here in the 4th quadrant. And we said before, this is probably some version of a 45-degree angle. So I would think that the answer would be here. And that's right. But did you call that 7 pi over 4? If you did, that's not right. Because remember, to draw 7 pi over 4, you have to start at 0 and go through, there's those two evil quadrants. I have so much fun doing this. You have no idea. You can't even go through those two quadrants because sine inverse doesn't play there. So you can't even draw 7 pi over 4. So what's another way of calling 7 pi over 4? Is by going this way. And the answer is negative 1 pi over 4. So if you're going to add one more thing to your notes on this, I would say if you're ever playing with sine inverse or tan inverse of a negative number, your answer is always a negative angle. Always. It's not 11 pi over 6 or 7 pi over 4. It's negative pi over 6 and negative pi over 4, which is a version of coterminal, which we talked about before too. Good job. Always like to end with a puzzle. Check these out. These seem like these are actually going to be tough, but they're not as bad as they look. I want to find the cos of, the tan inverse of 2 over 3, which looks terrible. And the worst part is we can't use a calculator. Ugh. All right, here's what we're going to do. Let's try this. Can you just focus on the inside here? And I'm going to give you a little hint down here. Why don't you use that blue box and why don't you make a triangle based on those sides? And over here on number 2, same idea. And the reason you know to do this is because you're given 2 different trigs and one of them's an inverse. So on number 2, when you try it, can you build a triangle on your own of just that given info? Now remember where cos inverse lives, remember where tan inverse lives, so which quadrant are you going to play in? All right, why don't you draw those triangles for me and label your sides and try to find all 3 sides and come back to me in about a minute. Pause this video and I'll see you soon. All right, welcome back. So here's what I got. Tan inverse is only in quadrants 1 and 4, and it's a positive 2 over 3. This is a positive number, so it's not going to be in quadrant 4. It's going to be over here in quadrant 1. All right, let's build a triangle. Here we go. Here we go. Right angle. Fine. Now this is tangent, TOA, so opposite over adjacent. So that means your 2 is going to be opposite, and your 3 is going to be adjacent. How are we going to find that leftover third side? You got it, Pythagorean. I don't think it's a nice one, but go for it. And I got square root of 13. Okay, well, when you do that, your triangle is done, which means let's go back to the problem. Watch. See ya. That's all you needed that for, was to build a triangle. Why don't we now just look at the regular part, the rest of it? What's the cosine of this triangle using the little inside theta angle there? Cosine, adjacent over hypotenuse. Cosine here would be 3 over root 13, or rationalize, how about 3 root 13 over 13? Final answer. So again, to review, what you did is you took the inside, what was inside the parentheses, and you build a triangle based on which trig inverse was it, which quadrants can we play in, and you got all the sides. Once you build your triangle, you can erase that inside the parentheses, get rid of it, and just refer to the outside trig. That's your last step. Pause the video and can you try number 2 on your own? And I'll see you back here. All right, hopefully you've already made the triangle based on what we did on number 1. Cos inverse lives in 1 and 2, but this is a negative number, and cosine is negative in the second quadrant, not the first. So I'm going to be playing over here, because cosine is negative over there. All right, let's build our triangle. Any right triangle will do. This is cosine. Cosine is adjacent over hypotenuse, so I want a 1 and a 5 and a negative. All right, I think I'm going to put, let's see, adjacent is 1, hypotenuse is 5, and then because this is going to the left, I'm going to make the 1 a negative. There you go, that's negative 1 over 5. Let's use Pythagorean. Let's find our leftover side, and I got the square root of 24, which reduces down to 2 root 6. Positive because it's going up. All right, I got my sides, negative 1, 2 root 6, and 5. My triangle is done. I can scratch this out and I'm good. Let's finish the problem. What's it asking for? The sine. Let's go look at your triangle and what's the sine of your triangle? All right, SOHCAHTOA, opposite over hypotenuse. I got 2 root 6 over 5. No need to rationalize. We are good to go. And that problem is done. Good job. The last part of this lesson is basically a repeat of what we've done before. How do you use the calculator to find the inverse? We've actually already done this way back when we did the law of sines and the law of cosines. We had to use the inverse trig in order to find angles. But just to remind you where it is on your calculator, It's right up here above sine, cos, and tan buttons, so you're going to have to use the second button, the blue second button, to reach them. But again, we've done that so many times, I think you'd be okay. So instead of actually doing these problems, which is just kind of boring work, just plugging them in, all you're doing is you're either changing mode to degree or changing mode to radian. Here's a challenge for you. Here's what I want you to do. Can you take each one of these 8 problems and just write down which quadrant is your answer going to be? How about that? Look at which trig you're using, which trig inverse, which quadrants does that trig inverse play in, and look at the number inside the parentheses. So therefore, your answer will be in which quadrant. So we're not using calculator, we're just using our knowledge of that diagram that we drew before, where we have sine inverse and tan inverse living in quadrants 1 and 4, and cos inverse living in quadrants 1 and 2. Pause the video, try numbers 1 through 8, and just tell me which quadrants your answer is going to be in. See you soon. All right, welcome back. So I'm looking at number 1. Tan inverse we know is in quadrants 1 and 4, and this is a positive number, so therefore that's going to be in quadrant 1. Number 2, sine inverse, again quadrants 1 and 4, but it's a negative number, negative 0.3. So it's not going to be in quadrant 1 where sine is positive, it'll be quadrant 4. And if you remember before, the answer here is going to be actually a negative angle. Remember on the previous page? But you didn't have to do that here. Number 3, cos inverse. Cos inverse, quadrants 1 and 2, right? But it's a negative number, so therefore it's got to be in quadrant 2. Finally, for this set, number 4, the sine inverse of 2. Well, this is a positive number, so sine inverse lives in 1 and 4, so this will probably be in quadrant 1. I'm going to put parentheses about it, because I'm going to talk about that more in class. That's kind of a strange problem. If you actually put it in the calculator, he would be very, very confused, but I'll explain that later. But the point is, sine inverse lives in 1 and 4. This is a positive 2, so it should be in quadrant 1. All right, let's try the last 4 here, folks. Again, we're in radians, but it doesn't really matter. I just want to know what quadrant we're going to play in. Ready? Number 5, tan inverse, quadrant 1 and 4, right? And it's a negative number, so definitely quadrant 4. Number 6, sine inverse, quadrants 1 and 4, positive number. He's in quadrant 1. Number 7, cos inverse, quadrants 1 and 2, positive number. He's in quadrant 1. And number 8, cos inverse, quadrants 1 and 2. He's a negative number, so he should also be in quadrant 2. But kind of like with number 4, there's going to be some problem with this one, and I'll explain that when we have our next Hun Zoom class time. All right, folks, that is the conclusion of section 6.5. Hopefully it went okay. Keep working on it. If you have any questions, you can always email me or set up a Zoom with me, or you can wait until the extra help time and Zoom with me then. But great job. Hopefully you did okay, and have a good rest of your day.